I'm kind of hoping you guys don't need me to go over a formula sheet. You basically use all the formula sheets you've used so far. Maybe redo them if you got points taken off. So I actually had a few people that used the formula sheet again, and they lost even more points. They just put it in a different color pen. So don't do that to yourself. Doesn't make any sense. It's kind of dumb. Don't do that. Yeah?
Which chi-square formula are we allowed to put on? Because that's the chi-square formula. Those weren't on the last one.
Oh, yeah. All right. There's only the one that we got to. Yeah. This guy. In later sections, there's another formula for chi-square. Just like Z has several different kind of formulas. Chi-square, this is the main one, but in a later chapter, when you do what's called goodness of fit tests, there's a different formula for chi-square. But this is the only chi-square formula we saw. Now, obviously, that's the formula for chi-square, but what do you use chi-square for? You use chi-square to make a confidence interval for this, right? And then how do you put that in there? So that's where we do what here? We just swap. So this will be, so you can add this to your formula sheets. And you can put underneath here whatever the hell you want to. You can put down there right, even though that's on the left side of the equation. Or you can put down there big. Whatever makes sense to you. So the book has right and left. I use big and small. Right. You can use this one, that one. I don't care. Whatever makes the most sense to you. Yeah, that's all you need for chi-square. Because if for hypothesis tests, we use this. For confidence intervals, we use that. I'm not catching. Yes?
Hypothesis test for example?
Yes. Because remember, this is like finding Z star. So you'll have this from the claim, and you'll have this from a sample. And a real quick word, I was trying to not create entirely different problems for this, but like for 9, part B, you do have to assume that, I don't want to get too much into this. You can see what I did there. We definitely didn't get into 2-sample chi-square tests. We did not do that. So on part B, I just assumed that the men's standard deviation was 11.56, and I'm testing whether the women had was bigger than that. Was sigma greater than 11.56? You can see what I did in part B for number 9. Yes.
So we do that. I think there was a problem like that before. We just did the same thing before.
Yeah. Do you know which one it was?
Number 9.
Really?
From 7.
Freaky. From 7? Well, 7 was a confidence interval thing.
Yeah, I think they always go because they have 2 different populations, but they just.
Well, that one's not. That one's only got 1, so I'm not sure which one.
I think I'll be fine.
Oh, I see. Okay, so the difference there was they weren't comparing the 2. They were create one for one, create another one for the other one, right? So that's fine. This one was actually test comparing the 2. So.
Okay, so you're saying make female 11.5?
No. So this one's saying that the females had a larger standard deviation than the men. So my claim then, I made it sigma greater than 11.56. Right? Sigma there meaning for the females. In reality, you'd have to do sigma 1 greater than sigma 2. But we don't even know how to do 2-sample chi-square tests. Right? It's the difference between chapter 8 and chapter 9, remember? What was with chapter 9? What's the main thing with chapter 9? What happens? The main difference. Chapter 9 was the 2-sample thing, so my z-score formula gets big, right? So can you imagine chi-square with 2 samples instead of 1. We don't even know how the hell to do that. Shit. All right, good. Hopefully you understand what I'm saying. So what I'm saying is you don't have to worry about that because we didn't do it. Cool. All right. So where do you guys want to go? Yeah.
Did you say homework for chapter 11?
No. 11 we're not going to get to. Yeah. I think I said really quickly last time that if you're going into education, if you're going into psychology, if you're doing those things, they're going to probably talk a lot about that. I at least wanted you guys to know what a chi-square distribution was. So if they start talking about chapter 11 stuff, they'll build on top of that. Yeah.
What was section 3-4 that we did?
All right, good. So that's what we were saying earlier.
Are we going to include that on the final?
Like we said earlier, we're going to do a problem from section 3-4, box plot stuff. Yeah. Let's do that. Let's get that out of the way. So what's a box plot need? Somebody remember? Good. It needs a 5-number summary. And a 5. And what was the 5-number summary? Good. Good. All right. So box plots came in that same section that we learned about percentiles. So this is the immediate use of percentile. So it's the visual comes out to look, like that, and then I can compare it to another population very easily. So if I compare these 2 populations, I'd say this has more variation, right? This mean seems to be higher. The median is higher for sure, but the mean probably must be higher because all the data values are bigger. You guys kind of with me? So it's a relatively quick, very informative picture to make. So let's do a problem and remember how the hell to do this. All right? So I'm going to give you the data in order. Be really careful if somebody in your near future gives you a list that's not in order. All right? That could very well happen to you somewhere. So, and why is it important for it to be in order? Yeah, so the median is an example of a percentile, and it makes sense. If I could just have it in any order I want to, I can make anything the median. What's your median income? $800,000. I put the CEO in it. It's like, oh, thanks for that. That's helpful, right? All right. So here's an example. So what do we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's do 12. All right. So nobody got 100. All right, so I'll help. The low is 42 and the high is 99. Okay, I did mine. Now how do you find these guys? You don't say, well, you put in the list and then you hit one of our stats and you scroll down. That's really good though. You will check your work. If you do that, if you do one of our stats and you scroll all the way down, the last 5 things it tells you are these things. If you didn't know that. So it's a way to check your work. Bless you. But how do you do your work? How do you get Q1? So what's Q1 mean? The first quarter. So how deep into the list do I want to go? 25% of the way in, right? So I take 25% of what? 12, because there's 12 data points. So if I want to go 25% of the way into my list, I take 25% of 12, because that's how long my list is, right? So if I do 25% of 12, I get 3. Does somebody remember what to do with that? Do I take the third number? Good. Third and fourth in average. So what's the third and fourth numbers? 50 and 51. So its average is 50.5. So there's Q1. 50.5. Let me stop there for a second. So remember, if it came out to be 3.2, what would you do? Take the fourth one. If it's not a whole number, you take the next number up. You round it up to the next number. If it's a whole number, you take that one and the next one average it. It's like you take the 3.5 number. Where's the 3.5 number? In between the third and the fourth number. Yeah.
So if it will be like 3.4 or 3.2, it will take the fourth number.
Beautiful.
51, right?
Yeah, you would just take 51.
Okay.
Exactly. Kick ass. All right. What's Q2? What's another name for Q2? The median. Cool. So again, I take 50% of 12, which is 6. So I take the 6 and 7. So what I have? 1, 2, 3, 4, 5, 6, 7. Their average is 60. 60. All right. And then Q3. Yeah, now watch. How far did I have to go in for Q1? 1, 2, 3, and I took the third and the fourth one. Now watch. For Q3, I go 1, 2, 3, take the third and the fourth one from that side. That's awesome. Totally. If you don't like that, you can do the work, but screw the work. I've already done it. I just come from the other side for that, right? Does that make sense?
Yeah.
A quarter of the way in from the bottom is the same as 75% of the way in from the top, right? So I would get, what did we just say? 1, 2, 3. There. What's the average of those two? 83. I like it. So 75%. No. Better way. We get 83. The average of these two. That's Q3. Let's let that sink in for a second. So if you did put these in the L1 in your calculator and you did 1 bar stats, scroll all the way down. These 5 numbers should be the last thing shown on your screen. Good. I like that. You're all like, I don't trust you, man. Only had you for 1 semester. I still don't know if you know what you're talking about. Every day I make this shit up. You ever realize that? No. All right. Okay, so how do I make the box plot now? What's beautiful about this box plot is it's stupid simple. When you get those 5 numbers, that's where you put what? And please don't do this. Don't do what I'm about to do. That's crap, right? You got to set up a scale on its own and then find your data. Your scale has to be consistent. So you can't say that this is 7 and then this is 28 and then this is 49 and then this is 2. The hell? Your scale has to be consistent. So maybe I'll start at 40 and I'll go up to 100. Well, that's craziness. Is that cool? Yes?
Wait, I don't understand the 83. Oh, wait. Are you just adding them? Oh, you just add them together?
Yeah, if you do the work here, 75% of 12 is what? So then you take the 9th and 10th and average them together. Those are the 9th and 10th. I just did it shortcut. I said I had to go 3 in from the top here. I'll just go 3 in from the bottom there and average those two. That's how you can do Q1 and Q3 really are the same idea from 2 different sides of the list. All right. So I go 40, 50, 60, 70, 80, 90, 100. So at 42, what do I put? A line. It's crazy. So I make it look like that. So at 50.5, I put a line. At 60, I put a line. At 83, I put a line. And at 99, I put a line. And the box goes around the middle 3, right? And it contains what percent of the data? 50% of the data. Because this contains This is Q3, right? What's Q3 mean? How much data is below Q3? 75%. How much data is below Q1? So how much is in the middle? 50%. So that's the middle 50% of the data. So if you look in like the Princeton Guide to Colleges, they like to say the middle 50% of SAT scores were from this to this. So they're saying Q1 was this and Q3 was that. That's the middle 50%. The heart. Right? Yes?
Sorry, can you repeat the graph? The graph part.
Alright, so are you cool with the scale?
Yeah.
Okay. And then I just put a line, 42, 50.5,
Okay.
60. Just put a line over the 83,
99.
right? 99. Cool. Box off the middle 3. And then here's your whiskers, so that's why math people always say, oh, it looks like a box of whiskers. Let's call it that. I don't know. That was a reenactment. All right. Okay, cool. It's really dependent on you guys, what you want to talk about. You tell me. What do you want to talk about? Yes? All right, so don't forget, we're going to have chapter 4 in this bad boy too. We're going to have some probability stuff. So everybody got this here? Okay. All right. So I'm going to try again. If two people are independent of each other, and one of them loses their job or something happens, what happens to the other one?
They lose their job.
It's like, you don't know, man. If they're independent, if I was dependent on this person, if I was dependent on somebody, and they lost their job, what happens to me? I'm in bad shape, right? Depending on how old I am, I have to go get my own job. Oh, man. Or I'm not old enough to get a job, and what the hell, I got to get some help from the state, right? Something's going to happen. You with me? If two people are independent, whatever the one does the other one care? No. Given that this person lost their job, the other person doesn't even know it, because they are independent of each other. Now, if it's a friend of mine, we are kind of dependent. If they are hurting, then it affects me, right? You guys see what I'm saying? I'm desperately trying to make this connect with something that we experience in everyday life. If I see somebody and I don't know them, and then a little bit later they trip over a stone and fall over and hit their head, if I didn't even see them, nothing happens to me, right? I don't feel a disturbance in the force. Not that I know of. All right, so coming back to math. What the hell does it mean in math? If I have two events, event A and event B, in order to test if these are independent, let's say, what's the probability of B given that A happens? So it's like, what's the probability that I live given that my caregiver lost their job, right? I mean, that kind of thing. It's a little bit dramatic, but that's what you got to do. If the probability B given A is the same as what the probability B was before, so right now there's a woman in the parking lot. I'll bet you a lot of money. There's a woman somewhere in a parking lot. You with me? Do we know this person? No, I don't know this person. So if they just lost their job, what will happen to what's the probability that I'm going to lose my job? Does it change?
No.
Right? You guys with me? So given that this person lost their job, what's the probability I lose my job? It's the same as it was. That didn't affect it at all, did it? All right, you with me? All right, let's get away from that before you guys say, well, what if that woman was your supervisor? Screw it. Get away. Stop. Let me come back and talk about this just straight math. Why does this make sense? if A happens and B stays the same, they are obviously independent of each other. Does that make sense? There's no reason that probability of B should ever equal probability A, and even if they did, what would that tell me? It wouldn't tell me anything, just because the probabilities happen to be the same. So I don't compare these probabilities. I say, what was this? Did it change if this happened? If it didn't change, then B doesn't give a shit about it. Whatever they are. All right, hopeful. And you know me. You know I'm going to do it again. Somewhere I ask you to do this. Somewhere I ask you to do this. And then the last question I ask is, are they independent? You just got to go back, and you've already done the work. You just got to go find it and tell me. Don't just say, no, because they're different. Wait, what? What's different? Show me, right? I can't assume that you're looking at the right place. Okay, maybe.
So, sorry, do the same things. They're independent.
I love it. So, if this is true, then independent. So if they are not the same, then they are dependent.
So if they are the same, they're
Independent. Then why does that make sense? Because this guy did something and he didn't give a shit, right? He lost his job, and I just keep going, I don't know this person. You with me? I'm not saying I'm an uncaring person. I don't even know they exist. You with me? I'm totally independent from this other person. I don't even know they exist. Not getting any metaphysics. I'm not getting any. But the auras, and no, I'm not getting into that. Right? The general human condition. No, I don't know. I'm talking about. Okay, maybe. So hopeful. So, I mean, you can look at the double quiz we did. And I told you, like, part A was probably sleep 6 hours, and part F was probably that they slept 6 hours given they were male. And it said, are those independent? You just got to compare those. What was the probably 6 hours? Did it change when I said it was a male? If it did change, then they are dependent. If it didn't change, if it stayed the same, they're independent. They don't affect each other. I might be a failing for me as a teacher, but I can't think of another way to say that. That's yes.
Do you do like a baseball with the probabilities of and versus old and stuff like
Okay. All right, let's do two different types. You know, one type I most likely will have something about on there is going to be like a table, right? Remember this? Let's say this is men, women. Let's say no, maybe. Pretty cool. You've seen this kind of problem a lot. And then I say, all right, so there's 4 men said yes, 11 women said yes, 18 men said no, 3 women said no, and 5 men said maybe, and 1 woman said all right. So I'll let you imagine up your own question. So if I start asking questions like what's probably, if I pick one person, what's probably as a man, what should I do first to get going into these kind of questions? Yeah, get all the totals, right? So here I get, and what does that mean? 15 said yes. Cool. Not 15 men. I don't see how those go together. Right? Or around the corner. No, men is that way. All right. How many said no? 21. And how many said maybe? 6. So how many total people are we talking about? 42, sweet. That's the answer. That's everything. What do we get here? 27, that's crazy. We get 15, and thank God these also add up to be 42. So I'll make it 84 people. Don't count everybody twice. All right, so what is probably I pick a man if I pick one person from this group? 27 out of 42 kick ass, and you can make that into a percentage, however you like. What do you get if you make it into a percentage? Huh? 4.9? 2.9? Okay. All right, so what about, so you asked for some questions like, what's probably I get somebody who said maybe, or somebody that's a woman. No, you're not thinking about or. Or is the nice bouncer. And is the mean bouncer. And is you got to be this, and the number of people get smaller and smaller and smaller. You got to be rich, you got to have nice clothes, you got to have a nice car, you got to look good, you got to have a lot of money. And then you get very few people that can come in, right? Yes?
So would or be the addition?
Yeah, or is basically add. And is basically multiply. But when it's in a table, you don't even need to use the formulas, really. You can be smart about it. Either I could do 6 plus 15, but why does that suck? If I do 6 plus 15, I've counted 1 twice. So I got to subtract it off. Or I could be smart about it and say 6 people plus these people I haven't counted yet. That would be 20. Which is what I get when I do 6 plus 15 minus 1. Either way you want to do it, you get 20. Whatever the hell that is. 0.49. Huh? Yeah, they're probably getting somebody who said maybe, or getting a woman. So what's probably going to get somebody who's a man who said yes? So what word is hidden here? Remember, this word gets hidden in the English language. And, because what does this person have to do? They have to be male and have said yes. Good, so there's an and hidden in here. So how do I find that in the chart real quick? Yeah, how many men said yes? 4. Out of how many people, what should go on the bottom? Beautiful, because I don't know anything about the person. It could be anybody. I'm asking what's the probability that they're this kind of person. But they could still be any of the 42 people. Good. So the only time that the bottom will ever change, not counting reducing, the only time the bottom will change is if I give you information. If I tell you that it's a man, I didn't tell you here it was a man, it's the probability it was this person. But if I say, what's the probability they said yes, given. So now I know it's a man. So how many people could it be? Total. How many people could it be? 27. Good. Because there's 27 men. It could only be one of those people, right? And how many chances do I have to get it right? How many yeses in that group? Go ahead. 4. So 4 out of 27. So the given on the bottom. Out of 27 people that are men, 4 said yes. That's why that's the probability. So remember that. The only time the bottom would change is if I give you information. Then you can throw people out.
Can you do the or again?
Yeah, so there are 2 ways to look at it. You could either do 6 maybes plus 15 women, but then I counted this one twice, didn't I? So I do 6 plus 15 minus 1. Or I do like 6 maybes plus 14 women I haven't counted yet. Either way I do it, I get 20. Just don't do this, 6 plus 14 minus 1. No. Now you're not counting that person at all. I like that. I don't know what there was something else he expected. It's like, I thought there would be entertainment. I'm sorry, no. I thought there would have been cookies. Nope. Yes. All right, guys. So, where else do you want to go?
Yeah.
Yes.
Can you do one of the independent planners? We already have the given.
Oh, good. All right. So now let's do right here. What's the probability they say yes? If I pick one person at random, let's probably get somebody who said yes. 15 out of 42. All right, how we doing? So now I could ask you, are saying yes and being I'm going to try to say it, being male independent? And this is where people will try to write me a little story saying, well, you don't have to be a man to say yes. You could be a woman and say yes. You could be transgender and say yes. You could be anything and say yes, Jeff. So no, you don't. No need to go there. Math cuts through all the shit. You just look at the math, right? So we just did all the math we got to do for this question. What was the probability of saying yes by itself? What's the probability of getting somebody who said yes by itself? 15 out of 42. Probably a yes. 15 out of 42. What's probably a yes given man? 4 out of 27. You probably got to take that down to decimal level. Let's see, what's 15 divided by 42? 35.7. 35.7. Okay. And then what's 4 divided by 27? 14.8. That's good. That's plenty to see. Are those, so what's the answer? They are so dependent. I really want you to get this. If this happened, if I tell you it's a man, did the probability that they said yes change? What was the probability they said yes when I didn't tell you shit about them? They were just a person. 35, 36%, right? If I tell you they're a man, does it change? Yeah, it totally comes way down, right? And I kind of set it up for that. You can see I was making sure that one was more than the other. You guys see what I'm saying? So this is like, when you do conditional probabilities, you're doing exploratory statistics. You're saying, given that the student went to the study center, what was the probability that they passed the course? If we see that that's higher, then we're going to try to push people to the study center course, right? Do you see what I'm saying? It's a very basic, quick study of correlations, really. And of course, we all know correlation does not imply causation, but you feel pretty good about if they get help, they'll do better. That kind of makes sense, right? Yes?
On the practice test, or the Bible, on 2C it says even number given given the answer was 2/3, but I'm confused how it's 2. You just do that.
So given that it's on green paper,
Does it like 3 even numbers, or are you putting 3 even numbers that are green?
so given that it's on green paper, how many were on green paper? 3. Out of those 3, how many are even?
3. Okay.
Cool. Yes, ma'am. Oh, to do the probability, right? Okay. All right, so these are dependent. So desperately dependent. Changed big time, right? Let's do this. It's going to be more like Alright. So we know that 59% of grossman students dropped at least one course. So why is this going to be a binomial situation? Because either the student did drop at least one course or they didn't drop at least one course, right? So that's going to be obviously binomial. I've got a P, so I've got a Q. I'm going to give you an N here in a second, right? So are you cool with me so far? So these kind of problems they normally kind of jump out at you. There's two situations. I've got a probability of success, so I automatically have a probability of failure. NPQ kind of problem. I know I attack that, right? So I say if we pick, what do you got, Jeff? 114 students in Grossmont. What's the probability that exactly, what, 67 dropped at least one class? So how do I set this equation up? Yeah, so this will be, how many people do I have total? 114. And from there I want to choose 67 of them to drop. Good, 0.59, and how many of those do I want? I want 67 of those, right? I want 67 to drop. So what's probably not dropping any classes?
1 minus 0.59.
Yeah. 1 minus 0.59, so that's 0.41?
Over 114 minus 67. Let's
Yeah,
take
so
the final
if-
right now. No, yeah, I'm ready now.
All right.
Yeah.
Calm down. I can go print you out one and put you to your work. So if 67 of them did this, how many did the other thing? Yeah, 114 minus 67. So 47. Cool. So just want to make sure everybody's with you, Arthur.
I'm ready now.
And now you just got to know how to plug this in the calculator. Some of you guys liked the factorial stuff, which is fine if you know how to use it. That's fine. If you don't know what the hell I just said, that's also fine. So is everybody cool with how to put this in your calculator?
Is it fine if we go to catalog and find for different?
Do what?
If we go to catalog, like second catalog,
And then find what?
The formula. It says that if you can use the cuddle bottom, you see the formula.
Now listen. If you set up the formula, but then you use binomial PDF or whatever, I'm not going to know and I'm not going to really care. If you don't set up the formula and tell me you used the calculator, I'll be like, that's nice for your calculator. I hope it has fun graduating, right? But you won't be joining it, right? You have to show me this. Whatever you do after this, as long as this is set up correctly, there's no way in hell I can know if you put this in there or if you use binomial PDF or whatever else, right? But you need to be able to set this up. Now, officially, I'd really want you to put this in your calculator, but how am I going to know? I'm not going to walk around next to everybody looking over their shoulder. I would hate that. Yeah?
Oh, can you just break that formula yeah.
So probably this many successes is the total choose that many. So I want X of these. And this is the weird part. I want the rest to be these. So it's going to be the total minus how many were there. That's how many's left over. So formulas, and I'm not saying anything against formulas. I obviously enjoy formulas or I would have picked a different job. But formulas very often make it seem harder than it really is because they have to be general. They have to cover every possibility, right? So that looks disgusting. That looks weird for people. But all it's trying to say is the rest. So if there were 20 and I want 7 here, then what's got to be here? 20 minus 7, the other 13, right? That's what that's trying to say in general. That's why it looks worse than it really is. So really, that's where we got 47 from, right? 114 minus 67. All right, cool. What do you guys, anybody put that in the calculator yet? 0.076?
No, point, yeah, 0.07.
6?
So,
Sure.
How long do you want?
How long do you think? 4. Hey, why 4? Because later we find that all the probabilities are in 4 places, right? So 0.07, 5.6. I was waiting for you guys to say 6.0 like it was a big thing. Same, huh? All right. Is that cool?
How do you find the calculator? But what about the binomial?
I'll show you that here too. Yeah. All right, let me show you how to put that in the calculator, and I'll remind you how to do binomial PDF. So you can check it. So what do we got? Oh, geez. 114. There you go. Where do I go for the choose? Math. Probability. Cool. NCI. 114 choose 67 times 0.59 to 67 times 0.41 to the 47. You guys with me? Is that cool? Or is that understood? Yeah, like that is very definitely not cool, Jeff, but understood is okay. All right. So there's like 0756. And now here's how you do it. You don't have to know this next part, but it's a nice way to check your work. If you go to second distributions, so right above bars, go to distributions. And then I want to go till I get binomial. What was the difference between P and C? Does somebody remember? P is particular, and C is cumulative. Right? So P is if I have a question about exactly, and C is if I have a question about, at most or at least something. Right, so I want binomial PDF, and my inputs are N, P, X. I don't have to tell it Q, it's a freaking calculator. They can do 1 minus. It's a freaking calculator. So 114, comma, 0.59, comma, 67. And you get the same answer. It's amazing. I like it.
What did we get there? Is it?
So right here, ready? Second. Bars right here. See where it says distribution above? Bam. While we're here, let me show you something. See this normal CDF? You guys remind me, what percentage is within, from -1 to 1 roughly? Within 1 standard deviation in a normal curve, what percentage is that? 68. So if you do -1 to 1, 68%.
Can you repeat that? Check to see.
I did PDF because it's exactly, it's particular value. CDF would be cumulative. It's not the same for NCI. Yeah, it's a different thing entirely. Yeah, that's why it's nice to not even worry about the binomial thing.
So what will be -1 and 1?
Well, what do you think? If it's within 1 standard deviation of the mean, what's the mean as a z-score? 0. So what's 1 step down? -1. What's 1 step up? 1. So what that means is what area is between -1 and 1 on the z chart. Yeah. I like it. Some teachers do entirely in here, and you guys are like, where are they, man? Why did I take you? And it's because if you use the table, you get a much more, you're much more connected to where your numbers are coming from. You actually, over time, you kind of get a feel for how things are laid out. And if you don't believe in that, I don't care. You had to do it anyway. Haha. And plus, I want to remind you guys, on that calculator handout I gave way a long time ago, that's up on the website, it's got that, what I just did. It's got the binomial stuff. It's got all the procedures in the calculator, right? So,
Where is that?
on the website.
Oh, okay.
Look here, so there's normal CDF. You could do it for ones that aren't z-scores. You can just -1 to 1, but if I put something in here, it'll be like any mean, any standard. I'm not going to spend any more time than I just did on that, because you have to show me the work anyway. I'm not testing you on if you're able to do that in your calculator. But it's really nice to know it's there. It's a way to check your work if you know how to use it. Just make sure I can see where all the numbers are coming from in your work.
Can we use it like on the test to check it? Or
You can't use that sheet, but you can totally use normal CDF all day long. Again, you're going to have calculators. I can't walk around and see what you're doing. Or I could, but I don't want to be that person. You're in college. You should be a little more self-reliable.
For the first test, you told us that we could use a calculator to get the mean, median, range, and all those stuff. So we use it on the final, or do you want us to do like the table?
You can use it to get the mean and the standard deviation, because I told you Chapter 3 was the last time I was going to force you to show me all the work. But like the box plot we just did, you have to get your Q1, Q2, you have to get your percentiles. You got to show me the work. You can check it on the calculator, but you got to show me the work. And it's not a lot of work, so yeah. But the standard deviation, good God, remember those days? Right? Where you had to do the whole table for the standard deviation? Yeah. So let's not go back there. We won't do that. Yeah, Dan.
We're allowed to use every formula sheet while we get
You're allowed to use every single formula sheet. You could put, as long as it doesn't bother anybody else, you can get giant paper and put one formula on each. And just kind of do like a weird old MTV kind of video. This one? This one? Oh, this one. Okay. Yeah. Yeah, I only had a few that I'm going to bring more on the day of the test, so I'll have those. Oh, yeah, of course. Yeah, the website that I told you about, you can go there and print it out, but I'll have extra hard copies in case you don't have access to, easy access to printers and stuff. Okay.
like, it never lets me disregard that.
What's it say? Does it say dim mismatch?
This error. Yeah.
Dim mismatch. So the lists have to be the same one. Because when you do two far stacks, it also does stuff about the product of the two. Because if you look at the formula for R, remember? Chapter 10, the one thing I let you do entirely in your calculator is get R in the line of best fit. So if you look at the formula for R, it's got terms in there where it's like sum of X, Y, the product of X and Y. So it has to multiply all the entries in the list. If they're not the same length, it freaks out. Yep. So if I'm you, what I would do to get ready for this exam is to make sure I understand. One big thing about this class is, when do the formulas change a little bit, right? Like, when do you change the standard deviation? When do you have to divide that by square root of n? When is that? When you take a sample and we ask questions or we're talking about the sample mean. right? So if I say we take 16 people, what's probably their average age is more than 20. Oh, I took a sample. I'm asking questions about the sample mean. Therefore, I must change the standard deviation. And we know it's built in. It's built into confidence intervals. It's built into the formula. Makes sense. Confidence intervals, how do we make it? We take a sample, and we're trying to talk about the mean. Holy shit, there you go. You're supposed to change the standard deviation. So we built it into the formula. You guys kind of with me? Because what's the formula for confidence intervals for a mean? I don't know, Jeff. Leave me alone. X bar, I'll start it off. X bar plus or minus? Built in, right? Built in. Because how do we get there? We take a sample, that's what it is, and we talk about the mean. Holy shit, so I've got to change. That's why it's built into the formula, because you're going to do it every damn time. What about step 4 in a hypothesis test about a mean? We have to change the standard deviation, don't we? Because how do I do a hypothesis test? I take a sample, and I'm talking about its mean. Oh shit, I've got to change the standard deviation. You with me? When do I change something by half a step? Like I say, probably at least 40, and you make it become 39.5. What's that? The NAB. I'm still going to be way too nice and actually say, use the NAB. Right? Some of you guys are like, you could be nicer than that, Jeff, but that is really nice. You should know if you have an NPQ problem and I'm asking you to use a z-score chart to do it, you have to use the NAB. What's NAB stand for again? National Association of Basketball. No. Normal approximation to the binomial distribution. So it could actually be nabbed. Why just make it nab? So it's when you have an NPQ problem, but I'm trying to treat it with z-scores. Why don't those go together? What are z-scores for? What kind of distribution is that for? Don't say normal. I'm sorry. For a continuous distribution, right? Continuous. And what does NPQ lead me to? Discrete. What's probably that 14 people, where you're not going to have 13.934 people. What happened? I don't care how many limbs you lost or what happened to you, you're still a person, or you are not a person, right? Okay, maybe. The quick answer is when I say so. But the long answer is when we're trying to use a z-score chart to find NPQ probabilities. Yeah. Cool. So on the praxis final, it's like number 4, I think? Yeah. Yes?
Are we going to have one that was like the probability of this minus 1?
Oh, sure, yeah. Like 1 minus?
Yeah.
The funny thing is, we should be very used to that idea by now, because we do it all the time. When we do z-score formulas, for 1 greater than, I got to do 1 minus the other side. So if I said, let's do, this is the kind of problem I wanted to do earlier for probability. If I have 3 locks on my door, the probability of any one of them getting broken into or picked, let's say it's let's say it's 1% chance. So there's a 1% chance somebody can pick that lock and get into my house. But I got 3 of those locks on my door, right? You with me? So what's the probability that at least 1 lock works? And what situation is that? What's the way I could have said that? What's the probability that the thief, if at least 1 lock works, what's going to happen? Is the thief going to get in? No, so I could say what's the probability that my house remains safe, right? As long as I'm strong enough just to take the damn thing off the hinges. Right? All right, we're doing okay so far? All right, so this is a neat problem. At least 1 lock works. What's the opposite of that? And why would I think about the opposite? At least 1 lock works would be sucky. That would mean the first one works and the other two I'll say works and doesn't work, right? Or maybe it's the middle one works. Or maybe it's the last one works. Or maybe it's the first two work, because it's at least holy shit. I don't want to do all that. It sucks just trying to write that much, and I'm not done yet. So, I desperately want you to understand, you can always do 1 minus the opposite probability. Not just when I say at least 1, that's when you do it the most. Anytime that the opposite probability has less work to do, of course I'm going to do that. And then do 1 minus to get the actual answer, right? I'm always going to do that. Hell yeah. So what's the opposite of at least one lock works? What's the opposite of that? The opposite of at least one works is they all don't work, right? None of them work. All don't work. I'm like, none work. Let me let that sink in for a second. If you wanted to prove somebody wrong, if I said, I think at least one lock's going to work, what's the only way I could be wrong? If I say at least one of them's going to work, what's the only way I could be wrong if none of them work? See, that's why it's the opposite, because that's the only way you can show that I'm wrong. Does that make sense? That's the way I think about opposites with these probability questions. How would you show that this person's wrong? If this is what they think, I'd have to show this. That's the opposite then. So how do I set this guy up? There's 3 locks, right? 3 locks. And I want all 3 of them to not work. Right? And this is the probability that it not work. So what do I put in each one of these? 0.01, 0.01, 0.01. Yeah, 1 minus 0.01 cubed. I like it. It's going to be a lot of 9s. Let's see. Yeah, it's like 9, 9, 9, 9, 9, 9? Okay. Well, why is that good? Because what's the probability somebody gets in my house? 1 minus that. Right? To get in my house, you have to get through all the locks. So that's the probability somebody gets in my house. I want the probability that the locks keep me safe to be very high. And this is why we have redundancy. If one of them fails, we want the other ones to pick up. Right? So we have redundancy in nuclear plants, thank God. Right? So if Homer doesn't do his job, something's in the way so that it's fine. It's redundancy, right? He has several people doing the same thing, maybe. Because somebody hired freaking Homer. Sorry, that's the only nuclear plant reference I have. So, another thing is the practice final is really good to start with. Like any practice test, you don't want to do these problems a lot because then you get to know that problem. And I'm not going to give you this problem. I'm not going to give you any of these problems on the test. They're going to be something like this. Make sure you understand the idea behind them, right? Yeah, I mean, you could do that. You can go to the review exercises. It totally depends on what you're good at and what you're bad at. Yeah. If you go to the review exercises, they should have all the answers to those in the back, so you can kind of check those if you want to do extra practice. Some of you guys didn't even do the homework I assigned, so I don't know if you're going to do that either. But you do what you need to for yourself. If there's homework you haven't done, you can go and just do the odd problems and turn that in. At least do that to get yourself ready for the final. Do it honestly, because you're doing it just to get practice. You're not doing it. If enough of it's good, I'm going to give you some kind of credit. If it's really, really late, you'll get something more than 0. But the reason I do that is because the final's cumulative. So if there's anything you haven't done yet, do it. Right? That goes for homework, corrections, any of that stuff. Yeah. Day of the final. On the day of the final, I'll have the spreadsheet up on the computer, so you can come up and kind of give a quick look over to make sure everything looks right. You with me? I'm not going to give you another printout, but I will have the computer, so if there is a problem, I can change it right there, and that will be my, you can see the change happen. Trust me, if you are a student, you want to put eyes on your teacher's grade records at some point. Because teachers are humans, and I've had teachers put tests in, I got an 86, and they put a 68 in the computer. I'm like, wait a minute, I got an 80, oh yeah, I'm sorry. And they're not evil, they're not bad, they're not anything. We're just human. Which is one reason why I give you that spreadsheet printout, so you can quickly see, that's not a 68, it's an 86. I'm like, oh shit, I'm sorry. I don't mean anything by it. It's just human. So I have the spreadsheet up here. Check your email. I'm going to send you guys my schedule for next week. Monday is a holiday, so don't come. Just study statistics. That's all. Anything else, you guys? Anything? Did anybody go to that stats the workshop? No. Okay. Y'all. Oh, you did. Was it good? It's probably different. Yeah, so you get like a little packet of stuff, right? And some of it is actually what I did on my calculator. Yeah, I think she was late, a little late, yeah.
I do one of the answers.
Yeah.
What were you saying about when do we have to change the standard deviation?
Yeah.
When do we have